Hey guys, this is Jaima from Mastery Math Lab, and in this video you're going to learn how to solve system of equations using elimination. But first let's talk about what is the system of equation. So if you notice the two equations that are given to you, these are two linear equations, and I know this because for both of them the highest exponent is 1. So since we are solving, what we're trying to do is what is their common point, meaning what is the value of x and y, their common point, that makes both equations true. So there are three possible answers for this. You can have exactly 1 point, no solution, or infinitely many solutions. So let's see what it looks like on a graph. So on the first graph, the two lines intersect at 1 point. This is their common point. And so that's the point that makes, or the x and y, right, that makes both equations true. This is exactly one solution. On the second graph, you have no solution because the lines are parallel. They don't intersect, so therefore there is no common point. And on the last graph, that actually happens when both equations represent the same line. And then what happens is you have those two lines connect or touch, or their common point is every point on that line. That's why it's infinitely many solutions, meaning all the x and y, or all the points on that line, satisfy the equations. But let's say you don't have the graph like you have in this situation where they're giving you the two equations. So let's see how you solve it, and in this case we're going to use the elimination method. So in order to eliminate or cancel one of the variables, they need to have opposite coefficients. So what do I mean by opposite coefficients? So let's say I have a 7y. Well, to cancel a 7y, I need to have a negative 7y. So if you notice, the coefficient one is positive, the other one's negative. So that's what I mean by opposite. So now let's look at our problem. So in our case, we don't have opposite coefficients, so we have to do something or manipulate the equation so we end up with opposite coefficients. I'm going to go for the x only because they have smaller coefficients and it's easier to work with smaller numbers. So what is the common multiple between 2 and 3? 6. So what I'm going to do is I'm going to multiply the top equation by 3, because 3 times 2 is going to give me 6, but the opposite of 6 is negative 6, so the bottom I'm going to multiply by negative 2. And when I say multiply on both equations, I'm talking about every term on that equation. So for the first equation, you get 6x minus 15y equals 18. For the second equation, I get negative 6x plus 8y, careful with your signs, minus 18. Okay, so now if you notice, the positive 6x and the negative 6x, they are going to cancel. So you're going to combine or add or subtract vertically. So I have negative 15y plus 8y. Well, that is negative 7y. And here I have 18 minus 18, that is 0. So my last step to solve for y, since I have negative 7y, meaning it's multiplying, opposite of multiplying by a negative 7 is dividing by a negative 7. So I get that y is equal to 0. But I'm not done yet because a point contains an x and a y. So I found the y, now I need to find the x. So you can plug in the y into any equation from the original problem. I'm going to go ahead and plug it into the top one. So I replaced y with 0. Okay, now I'm going to simplify. So negative 5 times 0, well, that's just 0. And then 2x minus 0, that's just 2x. So this 2x means 2 times x, so opposite of multiplying by a 2 is dividing by a 2. And so your final answer for x is 3. And the way you write your answer is 3, 0. What this means is that the lines actually intersect at exactly 1 point. It's always good to go back and the point that you found, go ahead and substitute it into the top and the bottom equation and make sure that it satisfies both. That's a good way to check your answer. Hopefully this helps. If you have more questions, please come into the Mastery Math Lab for additional help. Thanks for watching and have a wonderful day.